Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at some more examples of how we can use the sum and difference identities to solve problems. So in the previous video, we looked at some examples of how we can use the sum and difference trig formulas to solve some problems. Today we're going to look at a couple more, and we're also going to do some very basic sum and difference formula verifications, okay? We'll get to a lot more verification kind of stuff in later videos. But let's look at a couple more examples just to really get some more practice under our belt here. So again, here's our 6 formulas, the 3 addition formulas or the 3 sum formulas for sine, cosine, and tangent, and then the 3 difference formulas for sine, cosine, and tangent. And let's go through the process again of how we want to be thinking about these things here, okay? So starting here with, we want to find the exact value of the sine of 17 pi over 12. And again, I want to put emphasis on the fact that we're looking for the exact value, meaning that we don't just want some decimal approximation. So what we're going to do is we're going to look at the sine of 17 pi over 12. And we want to either find 2 angles on the unit circle that either add up to 17 pi over 12, or 2 angles on the unit circle that when we subtract them give us 17 pi over 12. And notice there's going to be a combination, more than one combination that's going to work. The combination that I'm going to look at when I think of 17 pi over 12, well, I see a 15 pi over 12, which is really 5 pi over 4 when it's reduced, and I see a 2 pi over 12, which is pi over 6 when that's reduced. And notice that 15 pi over 12 and 2 pi over 12 will add up to 17 pi over 12. So I'm going to add up pi over 6 and 5 pi over 4. So I'm going to say sine of 17 pi over 12 is equal to the sine of pi over 6 plus 5 pi over 4. And again, that's because pi over 6 is 2 pi over 12, and 5 pi over 4 is 15 pi over 12. And we can see that those very easily, or we can see very easily that they add up to 17 pi over 12, okay? So that means that pi over 6 is going to be our alpha, and 5 pi over 4 is going to be our beta. So let's now follow the addition formula for sine. The addition formula for sine says sine alpha times cosine beta plus cosine alpha times sine beta, where we already know what our alpha and beta are going to be. So let's just follow the formula. So sine alpha, or sine times pi, or sine of pi over 6 rather, times cosine beta, cosine 5 pi over 4, plus cosine alpha, or cosine pi over 6, times sine beta, or sine of pi over 4, or 5 pi over 4 rather, sorry. Okay, and let's start going to the unit circle and pulling off these exact values. So sine of 5 pi over 6, or sorry, sine of pi over 6 rather. So here's pi over 6. Remember, sine is the y value, so we're looking at 1/2. Okay, cosine of 5 pi over 4. Well, here's our 5 pi over 4. Cosine is the x value, so negative square root of 2 over 2. Let's get there we go. Negative square root of 2 over 2. Cosine of pi over 6. Pi over 6, cosine, square root of 3 over 2. And then sine of 5 pi over 4, which is negative square root of 2 over 2. Okay, now let's multiply. 1/2 times negative square root of 2 over 2, that's going to be negative square root of 2 over 4, minus, because we have this negative times a positive here, minus square root of 6 over 4. And we can see common denominator of 4. Let's go ahead and combine the numerators together. This is going to give us negative square root of 2 minus the square root of 6 all over 4. And this is our exact answer for the sine of 17 pi over 12. Okay, so not too bad. Typically sine and cosine problems, when we're doing these sum and difference identities, or sum and difference formulas rather, they're typically easier, okay? Now let's look at an example of a tangent problem, which tends to be the more difficult problems just because of the algebra involved. So we want to calculate or find the exact value of tangent of negative 105 degrees. So tangent, negative 105 degrees. Well, again, let's go look for two angles that are either going to add up to negative 105 degrees, or more likely, in this case, subtract to give 105 degrees. So let's do that. So what I'm thinking here, I see 135, and I see 30. If I do 30 degrees minus 135 degrees, that should give me negative 105 degrees. So that's what I'm going to go with here. Tangent of negative 105 degrees equals the tangent of 30 degrees minus 135 degrees. Okay, and that's going to make 30 degrees alpha, 135 degrees beta, and notice we are following a difference formula for tangent. So you can see that's right here. So let's just go ahead and follow this formula. So this is going to equal tangent alpha, or tangent of 30 degrees, minus tangent beta, or tangent of 135 degrees, over 1 plus tangent alpha, or tangent 30 degrees, times tangent beta, or tangent of 135 degrees. Okay, now let's jump over to the unit circle and pull off these values. So tangent of 30, well, here's our 30 degrees. Tangent's going to be this number over here in the rectangle, square root of 3 over 3. So this is equal to square root of 3 over 3 minus, now we want tangent of 135. Well, here's 135 degrees. The tangent's right here, negative 1. So minus negative 1. Let's be careful there with that double negative. Over, then we got the 1 plus tangent 30 times tangent 135. Well, we already know tangent of 30 is square root of 3 over 3, and we already know tangent of 135 is negative 1. So I'm just going to put plus negative square root of 3 over 3. We already know that we're going to multiply those together. Okay. So simplifying a little bit here, square root of 3 over 3 minus negative 1, that's just square root of 3 over 3 plus 1. In the denominator, we're going to be getting 1 minus square root of 3 over 3. All right. So working on simplifying this, we know we don't like this as a final answer for one reason. We have a square root denominator. We don't like that in math. So let's work on simplifying the numerator and denominator. I'm gonna start by changing each of these 1s into just 3 over 3. Just rewriting 1 to have a common denominator of 3. Now this is going to give us square root of 3 plus 3 over 3 in the numerator. And in the denominator, we're going to get 3 minus square root of 3 over 3. Okay, well, we can see that they both have denominators of 3 in each of those fractions. They're going to cancel out, and that's going to leave us with square root of 3 plus 3 over 3 minus square root of 3. Now, once again, this is really not a simplified answer because we still have the square root denominator. So let's multiply both the numerator and denominator by the conjugate 3 plus square root of 3. So essentially all we're doing is we're taking the original denominator, changing the sign in the middle from a minus to a plus sign, and multiplying that to both the numerator and the denominator. The reason we do this is because it's eventually going to cancel all the square roots in the denominator, which is really our goal here. We want to make sure there's no square roots in the denominator. But this means that we're going to need a FOIL. So square root of 3 times 3, that's 3 square root of 3. Square root of 3 times square root of 3, that's positive 3. 3 times 3, that's 9. And then 3 times square root of 3, that's another 3 square root of 3. All right, so there's our numerator. In the denominator, FOIL also. 3 times 3, that's 9. 3 times square root of 3, that's 3 plus square root of 3. Or plus 3 square root of 3, sorry. Negative square root of 3 times 3, that's negative 3 root 3. And then negative root 3 times positive root 3 is minus 3. Notice in the denominator, 3 root 3 and negative 3 root 3, they cancel. That's what we wanted to see. That's the whole point of multiplying by the conjugate here. We call that rationalizing the denominator. And let's go ahead and combine like terms in the top and the bottom. So 3 plus 9, that's going to be 12. 3 root 3 and 3 root 3, that's 6 root 3. In the denominator, 9 minus 3, that's 6. And we are almost done. I'm going to separate the fraction, 12 over 6 plus 6 root 3 over 6. Notice that those 6's cancel, 12 over 6 is 2, so we get 2 plus the square root of 3 as our final answer. Okay, so 2 plus the square root of 3 is the exact value of the tangent of negative 105 degrees. And again, you can kind of compare the work here between this sine example and this tangent example, and you can see that the tangent example required a lot more algebra skills, a lot more algebra proficiency. So, you'll see that with pretty much all these tangent examples, while these sine and cosine examples, when you're doing sum and difference formulas, usually tend to be pretty tame. And that's just the way it goes. There's a couple more examples. You'll have more to work through in your practice set. But let's take a look real quick at just a couple of very, very simple sum and difference formula verifications where we're going to do, little proofs. And again, we're starting pretty simple here. In the next few videos, you'll start to see more verifications pop up, and they'll start to get more complicated. But we'll start, introducing it with these simple proofs here. Okay. So here in example 3, we want to verify that the sine of 3 pi over 2 minus theta is equal to negative cosine of theta. So basically, we're trying to prove that this is equal to this. And when we do verifications, typically you start with the most complicated side and you try to work it down to look like the least complicated side. So we're going to take sine of 3 pi over 2 minus theta, and we're going to mess around with it until it looks like this, until it's negative cosine of theta. So that's what we're going to do. Let's start with sine of 3 pi over 2 minus theta. All right. Well, this is clearly a difference formula for sine. And if we follow the difference formula for sine, let's go ahead and call 3 pi over 2 alpha. Let's call theta beta. And let's just follow the formula. So sine of 3 pi over 2 minus theta, that would end up being sine of 3 pi over 2 cosine of theta minus cosine of 3 pi over 2 times the sine of theta. Okay, well, let's jump over to our unit circle because we can calculate the sine of 3 pi over 2. 3 pi over 2 is right down here. The sine value is negative 1. So this is equal to negative 1 times the cosine of theta minus, well, we can also calculate the cosine of 3 pi over 2. So again, here's 3 pi over 2. The cosine is 0. So minus 0 times the sine of theta. Well, 0 times anything is 0. This whole thing is just 0. So we can really just ignore that. And negative 1 times cosine of theta right here is just going to be negative cosine of theta. Again, we're ignoring the 0 here. That part is irrelevant. But that's exactly what we wanted to verify. We have reached the end. I'm going to do my little end of proof box because we're done. We've verified what we wanted to verify. In example 4, I encourage you to go ahead and try it on your own. You might have seen little glimpses of it here. We already had the work shown, but I would encourage you to pause the video, try it out on your own. Again, it's not going to be a very difficult verification. It's going to follow pretty much the same flow of logic, but give that one a try, then unpause it here in just a minute, or in just a second rather, and see if you got it correct. Okay. So here's example 4, where you want to verify that the cosine of 180 degrees minus theta is equal to negative cosine of theta. And again, you can see it follows very much the same flow of logic. We call 180 degrees alpha, we call theta beta. We follow the difference formula for cosine. So cosine of alpha, cosine beta, plus sine alpha sine beta, and we end up getting negative cosine once we work all the way through it. Okay, so again, these are just a couple very quick, very simple verifications, and we'll be getting to much more complicated and much more interesting verifications as we continue through the unit.